Hi, in this video we are going to solve the fourth problem of IIT JAM 2021 Mathematics. In this problem, we are given with a continuous function f from R to R which satisfies this integral star for all x. Now in this problem, first thing we can try is our quick method where we try to eliminate the wrong options by constructing an example. But this method is not going to help us much because if you look at these options B, C, D, they are actually about constructing an example which satisfies star and some additional non-trivial properties. In other words, no example is going to eliminate them because there can always be another example which satisfies one of B, C, D. On the flip side, if you try to look for example in favor of B, C, D, that will be a bad idea because in case B, C, D are not the correct answer, you will never be able to find one and you will just be wasting your time in the exam. Instead, what we can do is we can try to get something out of the given condition star and deduce some necessary properties of the function f. That's what we are going to do precisely. So for that, let's simplify the given integral. Now the integral is integration from 0 to 1 of f of xt dt. Now notice that the integral is with respect to t, but the argument of the function f is xt. So the most natural thing to do is that we know from integral theory is change of variable, right? Now for change of variable, we consider a special case separately. The case is when x is equal to 0. In this case, xt is 0 for all t between 0 and 1. So in that case, the integral becomes this: integration from 0 to 1 f of 0 dt, f of 0 being constant, integration from 0 to 1 being 1, it gives f of 0. And from the given condition star, it implies that f of 0 is equal to 0. Now, x equal to 0 is done. Now let us suppose that x is not equal to 0. In that case, we can perform the change of variable nicely. Let y be equal to xt. This implies dy is equal to x times dt. Remember, x is a constant here, so it remains as a multiple of dt. Now from here, we get dt equals 1 by x times dy. Remember, we have 1 by x because x is not equal to 0 and it all makes sense. Very good. Now the limit of the integral also changes from the change of variable. T goes from 0 to 1. This implies y is from 0 to x. Now that we have performed change of variable, we get the following. The given integral star is this. Now from the change of variable, we know that this integral is given as follows: 1 by x times integration 0 to x f of y dy equal to 0. Now multiply both sides by x. What you get is integral from 0 to x f of y dy is equal to 0. Now one thing we notice is that this happens for all x, and also the function f is a continuous function. This is a crucial observation which we will use in a moment. Now from here, we see that both the sides are functions of x. Let us differentiate both sides with respect to x. Take derivative with respect to x. So we have d by dx of the left hand side, which is integration from 0 to x f of y dy equal to d by dx of the 0 function. Now the fact that the left hand side is a continuous function implies that the derivative is given by f of x, which is equal to 0 now. This is known as the fundamental theorem of calculus. So what is the conclusion here? We have been able to prove that f of x is equal to 0 for all x in R. So yeah, we have proved that f must be identically 0 and A is the correct option.